Math 1, Unit 4, Lesson 5, Ready, Set, Go. In Math 7, you interpreted phrases that implied an inequality relationship. Remember that inequality symbols are used to represent different words in a written or spoken sentence. Words such as does not exceed or is at least represent both the possibility of inequalities as well as the possibility of equality. Greater than and less than represent situations that do not have the possibility of equality. Here are a couple of examples. I'm thinking of a number that is no more than 7. No more than 7 means that the number I'm thinking of is possibly less than 7, which would be represented with x is less than 7, or there's the possibility that I am thinking of the number 7 itself. This means that we also need to include 7 with our inequality notation. This is represented as x is less than or equal to 7. Now I'm thinking of a number that is at least 7. At least 7 means that the number I'm thinking of must be 7 or greater. Our resulting inequality is x is greater than or equal to 7. In our activity today in class, May I have more please, you wrote inequalities that modeled a situation. You also solved these inequalities. This ready section provides good practice for writing an inequality from a word sentence. Those ideas will be helpful in writing inequalities to fit these situations. Another thing to remember for this ready section is how to calculate the average of a set of things. For example, if I wanted to know the average weight of 10 apples, I would add their individual weights together and divide by the total number of apples. Let's take a look at a specific example similar to those from today's task and the situations in the Ready, Set, Go. Sally rides her bike 5 days a week. She wants to average at least 10 miles every day. The first day, she rode her bike 8 miles. The second day, she rode 12 miles. The third day, she rode 7 miles. And the fourth day, she rode 11 miles. How many miles does she need to ride on the 5th day to reach her goal? You need to write and solve an inequality that models the situation. Be sure to define the variables, then describe in words the quantities that would work in this situation. Write your answer in both interval and set notation. Parts A, B, and C are set up to help you make progress through the problem in a systematic approach. Let's start by writing the inequality. You need the average to be at least 10 miles per day, so we add all the miles biked on each of the individual days together and divide by 5, and make sure this calculated average is at least 10. We write this as 8 plus 12 plus 7 plus 11 plus x over 5, or divided by 5, is greater than or equal to 10. In the fraction, x represents the number of miles. Sally has to ride her bike on the 5th day in order to average at least 10 miles per day. When we simplify the addition, we get 38 plus x divided by 5 is greater than or equal to 10. Multiplying both sides by 5 gives us 38 plus x is greater than or equal to 50. When we subtract 38 from both sides, we get x is greater than or equal to 12. This is our answer for Part A. Part B asks us to describe what this solution means in words. This work tells us that Sally must ride her bike at least 12 miles on the 5th day in order to average 10 miles a day this week. Part C asks us to write our answer in interval notation and set notation. In interval notation, this would be the set from 12 to infinity. Notice the bracket on the left side indicates that we are also including the number 12, and the parenthesis on the right side indicates that we are approaching infinity. And in set notation, we would have x as the set of real numbers such that x is greater than or equal to 12. In the next unit, you will be working with many geometric figures that you should know from your previous work. In the Go section, you should rely on your prior knowledge and experience to match the name of each geometric figure with its definition, and then compare and contrast the shapes. Recall that triangles are three-sided polygons. Right triangles have a 90-degree angle. Equilateral triangles have 3 equal sides. Scalene triangles have no equal sides. And isosceles triangles have 2 equal side lengths. Quadrilaterals are 4-sided polygons. Parallelograms, rectangles, squares, and rhombi all have opposite, equal, parallel sides. Squares and rectangles have all right angles. Squares and rhombi have all equal side lengths. Trapezoids have only one set of opposite parallel sides.